Here's a practice problem from your homework, 4.2, multi-step equations and angles of polygons. So we have what I call a spider's web. I don't know what other teachers call it, but a series of triangles that are all running along this line segment, and there are some angles that are given to us and other angles that we need to be able to find through a couple of our different theorems that we've been working with. So one of the theorems we've been working with will help us find this angle right here. It's not an angle that is listed as one of the 5 angles we're supposed to find. However, we're going to find this angle using the triangle sum theorem. So right now I see that I have a triangle here, and I'm going to write up a small equation of 60 plus 80 plus, call it x for a moment, x equals, the triangle sum theorem says the sum of the interior angles of any triangle is 180 degrees. So, knowing that, we can set this equation equal to 180. Now, you may remember in our notes that we had another theorem called the exterior angle theorem. And if you remember the exterior angle theorem, then you don't really need to do this. There's a simple bit of math that would immediately tell us this angle. But assuming we don't remember that, here's the other way to do it. So I'm going to combine like terms, and I would have 140 plus x equals 180. And we're going to isolate the variable like we've been doing when we're solving equations. So I'll subtract 140 on this side of the equation. I'll maintain balance by subtracting 140 on the other side. 140 minus 140 is an additive inverse pair, so they cancel each other. They become 0. 0 plus x is simply x equals 40 degrees. So now, instead of an x there, we can write 40. What good does that do us? Well, this is a line that has been cut into 2 angles. We've been calling that a linear pair. And by definition, a linear pair are 2 angles that are adjacent and supplementary. So these 2 should add up to 180 to form that line. So quick subtraction, 180 minus the 40 degrees should be 140 degrees. So I'll make a little answer key over here. And the measure of angle 1 equals 140 degrees. Measure of angle 2, 3, 4, and 5. Please pardon my lack of writing a measure of angle there for the speed. Okay, now we have 2 different thoughts. Hold on! I'm back. Okay, we have these two line segments intersecting each other, and because of that, we have something known as vertical angles. Now, sure, we do have another pair or another linear pair. If you look this way, you would say the 140 and the angle 2 make a linear pair. That's true. So you could think of it that way and do another quick subtraction problem, or you could remember the vertical angles theorem. It says that when you have a set of vertical angles, and I could call them within an intersection the 2 opposite angles, I guess, that they are always going to be congruent, no matter how that intersection occurs. So whether you look at this linear pair or you remember vertical angles, this should be a 40-degree angle. Okay. So now we're moving on. We've already done angle 1, we've already done angle 2, and now we're on angle 3. And I have 2 unknowns. So if I called this y, we've already had an x. So I would say 40 plus the measure of angle 3 plus y equals 180. Well, I have to tell you, you can't solve an equation with 2 different variables in it. We've talked before in class that x plus y equals 10 has infinite solutions. You could have 1 plus 9, sure, but you could also have negative 200 plus 210 equals 10. That if we have 2 different variables in an equation, suddenly there's not one answer, there's infinitely many possibilities. So we're going to need to find some other information. And because of linear pair, here, we can find that. Again, we have this long line segment. It's being broken into two angles, 105 and an unknown. So we'll use that thought. Our line, 180, minus the 105 of the first angle, gives us its adjacent angle of 75 degrees. Now, we can use this to eliminate one of those variables. If we put a number in here, then we're down to an equation with one variable, and we can solve it. So, we have, thanks to our friends, the commutative property and the associative property, we can combine those two, which would be 115 plus the measure of angle 3 equals 180. And then again, I'll subtract 115 on both sides. And we'd have the measure of angle 3 is equal to 65. So now I have, where did that go? Oh, here, 65 degrees. I forgot what I was doing. 65 degrees. Now, quick check